This lesson is 5.1 in Go Math. The directions for the first section are to model factors. It says use tiles to find all the factors of the product. Record the arrays on grid paper and write the factors shown. So let's go ahead and look at number 40, so number 3, and I'll show you how to find the factors and then draw pictures of what it would look like on grid paper. So for number 3, we're going to do 45. Let's go ahead and draw a factor smile. I'll do blue today. Okay, 45. We always start with the number 1 when we're finding factors. So 1 times what is 45?
45.
Yeah, 45. Okay, and then we go to the next number after 1. 2. Is 2 a factor of 45?
No.
How do you know it's not?
Because it's not even at the end.
Yeah, the ones place value is not an even number, so we know 2 is not. What about 3?
Yes.
What's the trick with 3?
Add them. You add them.
Yes, if you can add the digits 4 and 5, and the answer is divisible by 3, then 3 is a factor of 45. So is 4 plus 5, what is it, 9? Is 9 divisible by 3?
Yes.
Yes, it is. So let's go ahead and write over here 45 divided by 3. 3 goes into 4 how many times? 1. And 3 times 1 is 3. And then 4 minus 3 is 1. Bring down the 5. 15 divided by 3 is what? 5. So we have 3 and 15 is our factors of 45. Okay, how about 4?
No.
Well, let's go through it. 4 times what is close to 45?
14.
4 times 11 is 44. And 4 times 12 is
45.
48. Okay, so 45 is, 4 is not a factor of 45. How about 5? Is 5 a factor of 45? How do we know?
Because the last one ends in a 5.
Yes, the digit in the ones place ends in a 0 or 5. So we know 5 is a factor of 45. We might not know what it is though, so let's go ahead and divide. Or we do, huh? 5 times what is 45? 9. So 5 times 9. Okay, let's go to the next number. 6. Is 6 a factor of 45? How do you know?
Because number 2 and
Yes.
number at the end.
Yes, if 2 and 3 are factors of a number, then 6 is also, and 2 is not. So we know 6 is not. We also know 6 times 9 is 54. 6 times 8 is 48, so that's really...
So is that our smiley?
We're not done yet. Let's check. What about 7? Is 7 times anything 45?
No.
No, 7 times 7 is 49.
And then 7 times 6
Is 42. Good. 7 times 6 is 42. So 7 is not. And 8? Nope.
No, because 8 times 5 is 40.
Yes, 8 times 5 is 40. So we know that 8 is not. So we are all done finding our factors for this. Yes. Okay, so if we were to draw this on grid paper, we would have 1 row of 45. We would have 3 rows of 15. And we would have 5 rows of 9. That's what it would look like. Okay. Okay, let's look at number, which one? 20, should we do number 6?
Yeah.
Okay, let's do number 6. So let's find all of our factors of 36. We always start with what number?
1.
1 and
36.
36. Is 2 a factor?
No.
Yes, it is, because the ones place value is an even. So 2 times what is 36?
13.
Let's think. It is 18. Yep, and if we were to divide it, we would get 18. How about 3? Is 3 times anything 36?
3 times 12.
Yep, and what is our clue with 3s? Do you guys remember?
Add them.
And yes, so if we were to add the digits 3 and 6, we would get 9, and 9 is divisible by 3. Good. How about 4?
Yes.
Is 4 times anything 36? Yes, 4 times 9. Okay, what's our next number?
5.
5. Is 5 divisible?
No, it doesn't
No.
have 5 or 0.
Yes. There is not a 5 or a 0 in the ones place, so 5 is not. What about 6? Yes, 6 times what? 6. So 6 times 6. So we know we have all of the factors of 36 because we've gone all the way around and connected those numbers. Now you would draw 1 row of 36, 2 rows of 18, 3 rows of 12, 4 rows of 9, and 6 rows of 6. Okay, let's just look at number 10. Eduardo thinks of a number between 1 and 20 that has exactly 5 factors. What number is he thinking of? Okay, so is it 1?
No.
Is it 2?
No.
No. Is it 3?
No.
4?
Yes.
Well, hold on. In 4 we have 1 and 4 and then 2 and 2. So that has 4 factors. How about 5?
Yeah.
No, because 5 is prime actually. What about 6?
No.
6 again just has how many factor pairs?
2.
2. 7?
No. Prime.
7 is prime. 8?
No. 2 pairs.
Only 2 pair. 9?
No.
Nope. How many pair?
2.
2, because we have 1 and 9 and 3 and 3. What about 10?
Yes.
Well, hold on. Just before you shout it, let's think about it. 10 has 1 and 10 and 2 and 5.
And 2.
No. Okay, 10, 11. 11 is prime. What about 12?
Yes.
12 has 3 factor pairs, so it actually has 6. Well, let's see. Yeah, it does, because it has 1 and 12, 2 and 6, and 3 and 4.
It has 3 down and 2.
So it has 3 factor pairs. How about 13?
No.
Prime. 14.
2.
Yep. 15.
Prime. 3.
Nope.
No. 3.
That has 1 and 15 and 3 and 5. What about 16?
2.
Let's see. Let's see. We have 16. So we have 1 and 16, 2 and 8, and 4 and 4. So,
6.
do we have 5 different factors?
No. We have 3 different factors.
We have 5. We have 1, 2, 3, 4, and 5.
Why didn't you
4, well, I've got 4 times 4. It's the same number, so it's the same factor. It's the same factor. We just count it 1 time because it's the same number. Okay, we do have 3 factor pairs, but it is the same number. So what is the number that he's thinking of?
6.
And you have to prove it with your factor smile. So 16 is the number. Okay. And then number 11, it says, have students write the answer to the essential question and draw examples to explain their answers. So the essential question was on your math book. And it was to,
How you can use models to find factors.
how can you use models to find factors? So you're going to draw a model to find factors for number 11. Okay, good job.